All right, hi everybody. In this question, we're just asked to solve it. Notice that this has already been factored. I've got this factor times this factor equals 0, which means I can split this up into 2 sine theta minus 1 equals 0, and the tangent of theta minus 1 equals 0. And then I can solve those individual equations here. Now, before I get into this, though, I want to take a look at my domain and what the domain is telling me. Okay, first of all, I recognize that those angles are in radians, so I know that this question's in radians. But notice what this is doing here. Negative 2 pi tells me that I've got a full negative rotation in my domain, but out to positive 2 pi means that once I've done that, then I'm also going to do a full positive rotation in my domain. So I'm basically going around the full circle twice here, once negatively, once positively. Now I go to my equations here, and I can see from here that this is going to be sine of theta must equal 1/2. I know that this is true in quadrants, this is positive, sine is positive, and I know that's going to be true in quadrant 1 and in quadrant 2. Okay, meaning that I'm going to have an answer here and here. Don't know exactly where that's going to be, but I'm going to have an answer in that quadrant and that quadrant. My reference angle for this is going to be pi over 6, which means what I'm doing is I'm chopping the top half of the circle into sixths, okay? And then I would also be chopping the bottom half of the circle into sixths. So now I'm going to follow these arms of my domain here. First of all, I'm going to do the negative one. So following this negative arm here, I come over a full half circle. That's going to be 6 of those pi over sixths, okay, just to get to here. And then I've got an additional angle here. So if I come over here, that means I'm going from here all the way around to here, and count that out. In the second quadrant here, this is going to be negative 7 pi over 6 to get there. Then you follow that around. We keep going around this part of the domain, and basically we're back into the first quadrant. If you go all the way around here, to get into the first quadrant, this is the angle that we're moving towards. This is going to take us all the way around to here, and count that out. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 11. This is negative 11 pi over 6 to get to that terminal arm. Now those are the two angles that we get just from following that negative rotation. Now we're going to follow the positive rotation. And in the first quadrant, this is nice because the reference angle and the rotation angle are exactly the same. So this is just going to be pi over 6. And then we come out here to my reference angle in the second quadrant. Now going back to this little diagram here, that would be going from here out to here, so that there's a reference angle of pi over 6 between the terminal arm and the x-axis, just the one there. And if you count that out, that's 1, 2, 3, 4, 5 pi over 6s to get into the second quadrant. Okay, so those are the 4 solutions that go with this part of the equation and that domain. Now let's take a look at tangent. Tangent of theta is equal to positive 1. That's going to occur in the first quadrant now with a different terminal arm. Now, I know someone's going to complain and say, I know I've drawn those in the wrong spots, and yeah, that's okay, whatever. I just need to know that it's in the first quadrant and in the third quadrant. And I would write that out here. First quadrant and my third quadrant. Now, my reference angle is going to be pi over 4. Okay, that's what goes with tangent here. And what that means, if I come over here, is I'm going to cut the top half of the circle into quarters and the bottom half of the circle into quarters. Now, in the first quadrant, if I follow the negative rotation here, because remember, I have to follow the negative rotation and then the positive rotation. To get to this in the negative rotation, I'm coming around, all the way around to here. That's 1, 2, 3, 4, 5, 6, 7. Negative 7 pi over 4s to get out to that terminal arm. If I want to do it in the third quadrant, that would just be follow this over here out to here, 1, 2, 3, just negative 3 pi over 4s. Now I jump onto the positive rotation. In the first quadrant, again, just like it was previously, that's the easy one here because the reference angle is the rotation angle. So that's just going to be 1 pi over 4. But to get around to the third quadrant, that would be 1, 2, 3, 4, 5 pi over 4s to get me into the third quadrant. And so here are all my solutions. Notice that I've got 8 of them. Okay, and you can see that here. Okay, each line here, I've got 4 different terminal arms and each one hits the domain twice. That's a total of 8 different angles.